Okay, lesson 5 is representing subtraction. On 5.1, it says, consider the equation 2 plus 3 equals 5. Here are some more equations using the same numbers that express the same relationship in a different way. So think of your fact families that you learned way back in elementary school. So if 2 plus 3 equals 5, I know that 3 plus 2 equals 5. Then I may also write it as subtraction. So since the sum is 5, my subtraction will start with 5. So 5 minus 3 equals 2, and 5 minus 2 equals 3. So it says for each equation, write 2 more equations using the same numbers that express the same relationship in a different way. So 9 plus negative 1 equals 8. So I know I can switch those numbers. Negative 1 plus 9 also equals 8. And then there are also 2 subtraction problems. So since the sum is 8, I know it's going to be 8 minus, and then each of your 2 numbers. So 8 minus negative 1 equals 9. And 8 minus 9 equals negative 1. Negative 11 plus x equals 7. So same thing, I can change the order. X plus negative 11 equals 7. And then I can write my subtraction. So 7 minus negative 11 equals x. And 7 minus x equals negative 11. On 5.2, it gives us an unfinished number line diagram that represents a sum of 8. And it wants to know how long the other arrow should be. So I know starting out, my number would be 3, because my first arrow is from 0 and stops at positive 3. And I have to get to positive 8, so if I draw an arrow from 3 to positive 8, then I have to figure out how long that arrow is. Well, I know I started at 3 and traveled to 8, so 1, 2, 3, 4, 5. So my arrow should be 5 units long. For an equation that goes with this diagram, May writes 3 plus question mark equals 8. Tyler writes 8 minus 3 equals question mark. So I want to know if you agree with either of them. So the correct answer would be that they are both correct, because if you think back to your fact families, then I know that both of these equations represent the same value. What is the unknown number? Well, we know that since we had to move 5 units to the right to reach 8 from 3, then I know that it has to be a positive 5. If my arrow had moved left, it would be a negative 5. So my unknown number is positive 5. On number 2, it gives us 2 more unfinished diagrams that represent sums. So on the first diagram, we have an arrow that goes from 0 to negative 3, and then an arrow from 0 to positive 3 on the second diagram. So for each diagram, we have to write an equation using the reasoning that May used, and then also an equation using Tyler's reasoning. So for the first diagram, I know that I start with a negative 3, and I know I have to add something because my sum is 8. So I know 3 plus that number must equal 8. So to think of how Tyler would write that equation, we know that he wrote it as subtraction. So his would be 8 minus negative 3 equals x. For diagram 2, first arrow moves from 0 to positive 3. So I know I start out with a positive 3. So it would be 3 plus some number will equal negative 8. So when I draw my arrow to negative 8, I know that I traveled 3 spaces to get to 0, and then 8 more spaces to get to negative 8. So that would be 11 units, which right now we just use x. So 3 plus x equals negative 8. So Tyler would have written, we have to start with negative 8. So negative 8 minus 3 equals x. So on C, I skipped ahead, but it says, how long should the other arrow be? So in the first diagram, we had started at negative 3, and we had to travel all the way to positive 8. Well, again, we travel 3 units to get to 0, and then 8 units to get to positive 8. So that's a total of 11 units long. For the second diagram, it was the same thing, 11 units. So D wants to know what number would complete each equation. So negative 3 plus what equals 8? Well, I know when I was up here at negative 3, I had to travel 11 units to get to positive 8. And I traveled in the right direction. So therefore, my number would be positive 11. For diagram 2, I also moved 11 units. But this time I moved to the left, which means the value would be negative 11. So negative 3 plus positive 11 equals positive 8. Positive 3 plus negative 11 would give us negative 8. Number 3 says draw a number line diagram for negative 8 minus negative 3. And then find the unknown number. When I do number line diagrams, I prefer to use the addition version so we can rewrite this. So if the subtraction problem starts with negative 8, I know that has to be my sum for my addition problem. And the only other number that I have given is negative 3. So that tells me negative 3 plus a number must equal negative 8. So then I can complete my number line. So 0 to negative 3. And I don't know what I'm adding, but I know that I have to finish at negative 8. So my arrow from negative 3 to negative 8, then I can count. So that's 1, 2, 3, 4, 5. So my arrow is 5 units long. Therefore, x must equal 5. But since I moved to the left to get there, it's actually negative 5. So on 5.3, it says to match each diagram to one of these expressions. So I personally prefer to go ahead and change my expressions. So again, that's a sum. So 7 plus x equals 3. And then same thing here, except it's negative 7 plus x equals 3. So let's look at diagram A. So my first arrow goes to positive 3. And then I move a certain number of units to the right, and I land at positive 10. So I can just count. So that's 1, 2, 3, 4, 5, 6, 7. So I started with 3. And I moved 7 units to the right, so that would be positive 7. So 3 plus 7 is for diagram A. So diagram B. So this one is unfinished because there's only one arrow. But I know my first arrow goes from 0 to negative 7. And so I know I have to add an unknown number, and that unknown number must help my equation equal positive 3. So as you can see, this fits the last equation. Because when I move my arrow, it would look like that. So on diagram C, I start out at positive 3. I'm moving to the left with my second arrow, so I know this is going to be a negative number. And I move 3 spaces to get to 0, and then 4 more to get to -4. So I moved -7 units, or 7 units to the left. So that means diagram C matches 3 plus -7, which tells me that the next equation must be for 3 minus 7, which is also 7 plus x equals 3. So as you can see on D, my first arrow stops at +7. And I know I have to add something that would get me back to the 3. So to get from 7 to 3, I have to move to the left. And I know that's 1, 2, 3, 4 units. But since I moved to the left, it would be -4. So 7 plus -4 equals 3, which is the 7 plus x equals 3. And I know that my x is -4. So number 2 says, which expressions in the first question have the same value? So let's look at the value of them. So we have 3 plus 7, which we should know is 10. 3 minus 7. So that was diagram D. So 3 minus 7 was -4. 3 plus -7, which was diagram C, which was also -4. And then 3 minus -7, diagram B. So 3 minus -7, which was also 10. So these two are the same. And these two are the same value. Okay, I want you to complete each of these tables. So 8 plus -8, since that's adding opposites, we know that my answer is 0. 8 minus 8, so if you have 8 items and someone takes 8 away, you're left with 0. 8 plus -5. So if I'm on a number line at +8 and I move 5 units to the left, I would end up at +3. 8 minus 5, again, +3. So let's move to this table. We have -5 plus 5, which again is adding opposites, therefore it's 0. -5 minus -5. That is also 0. -5 plus 9. So if I'm on my number line at -5 and I move 9 units to the right, I would finish at +4. -5 minus -9, which is also +4. So just comparing these two expressions. So if you notice, the -5 stays the same. But look at what happens to the operation. One's addition and one's subtraction. And then if you look at your second number, I have +9 and -9. Yet my answers are the exact same. So that's because when you change between addition and subtraction, you use the opposite. So since subtraction is the opposite of addition, your second term, you must use the opposite of it. So for example, if I have, let's say, -14 minus 3, I would want to change that to addition so that I could complete a number line diagram. and so that it's easier to think about number lines when I'm solving. So if I have negative 14, that would stay the same. I would want to change my operation to addition. And then since this is a positive 3, I must also change this to the opposite, which would change to negative 3. So negative 14 plus negative 3 would give me the same value as negative 14 minus 3. Same thing if I had 12 plus negative 7. If I wanted to change that to subtraction, so my first number stays the same, 12, change my operation to subtraction, and then use the opposite of the second number. So the opposite of negative 7 is positive 7. And those would both give you the same value. So I just want to remind you, up here, when we had subtraction problems, I had you change them to the addition in the fact family so that it was an equivalent expression. But when you're solving expressions, so if you have, the 8 minus 12, you'll want to rewrite that as addition, especially if you're solving it on a number line. So by doing that, that's when you can just use the opposite instead of changing the expression. So it would be 8, opposite of subtraction is addition, opposite of positive 12 is negative 12. And then same thing here. If you want to change addition to subtraction, which should not really be the case. Usually you change subtraction to addition. So negative 5 plus 2, first number stays the same. If you change that to subtraction, you now must use the opposite of your number. So opposite of positive 2 is negative 2. If you're subtracting a negative, make sure you put parentheses around your negative number so that you can separate these two marks. Okay, so lesson 5 summary. The equation 7 minus 5 equals question mark is equivalent to question mark plus 5 equals 7, which is illustrated in the diagram. When you work with number line diagrams, like I mentioned before, it's easier if you change it to addition first. So rewrite it as an addition statement, and that makes using number lines much easier.